Okay, here we go with part 2 of the review. Hopefully it will work this time. Looking at these, we're going to evaluate the limit. I know you've just learned these, and that's okay. We're just looking at the basic idea. So here, with 1 over x, like we talked about in the limit video, you need to understand what that parent function looks like. Okay, it's these curves. We have asymptotes along the x and the y-axis, so it's never going to touch either axis. So as you think about as the limit approaches infinity, then you've got to look and say, okay, as x approaches infinity, my graph kind of comes down and goes out, and it's going to continue to go this way and approach 0. It won't ever touch 0, but because it's approaching and getting infinitesimally close, we're going to say that limit equals 0. On 12, whenever you have an x squared over an x squared or an x over x, you're going to go ahead and just factor it, because if you plug -5 into the denominator here, you would get 0. So this factors to x plus 5, x minus 2 over x plus 5. Okay, those will cancel out. You would have a hole. This is a graph of line with a hole at -5. But for here, we're just left with that x minus 2. So we can go ahead and find the limit where x is equal to -5. So -5 minus 2 gives me -7. So the limit of this function is equal to -7. That tells us that in a graph down here at -5, -7, we would have a hole. Okay, but the graph is approaching a y value of -7 there. On 13, he throws an outlier problem in here where you cannot use the formulas he gives you in the back of the book. You just have to compute each term, so you would have to plug in 1 squared minus 1 plus 2 squared minus 1 plus 3 squared minus 1 plus 4 squared minus 1 and compute that answer, which is fine, except you don't know that you're not allowed to use the formula on that because this is an I squared instead of just a linear, like a 2i or whatever. So we're going to change this problem to be 2i minus 1. When we do this, we use the formula. Again, this is a formula in your formula chart. The formula in your formula chart is, I'll write it down in just a minute. It's A sub 1. Oh, my goodness, this kidding. Okay, it's N times A1 plus AN over 2. I didn't actually write the formula down. I just used it, so it took me a minute to remember the letters. Okay, so our N is the number of terms. We have 1, 2, 3, 4, because we go from 1 to 4. So my N is 4 terms. My A sub 1 is if we plug in our first number, which is here, 1, 2 times 1 minus 1 is 1. A sub n would be our A of 4 because that's our final term. 2 times 4 minus 1 equals 8 minus 1 is 7. Okay, and we know that my n is 4, so now we're going to plug this into the equation. 4 times 1 plus 7 over 2. 1 plus 7 is 8, times 4 is 32, divided by 2 is 16. So that is the sum of those terms. So again, I changed the problem on this one so you can use the formula that's in the back of your book. Please know that on the test I'm going to give you one more like that. 14, I want the exact answers here. You could type sine of 135 into your calculator. You're going to get a decimal number. Same with cosine of 60. I do not want decimals. I want exact answers here. And I can also spell. That is what I want you to do. So this is where using your unit circle is very handy to do that. And to also remember those. I kind of gave you a shortcut list before. So if we come over here, we're going to make like a little notes of things to remember. We've got in any... oh my goodness, y'all, I don't even have a brain today. So we've got, if we think about our units along the unit circle. So you've got your unit circle, we've got our pi over 6, pi over 4, pi over 3, all the things that go around. We can find our sine and cosine from the values that go with those. So pi over 6, anything pi over 6, it doesn't matter what the number is, any number pi over 6 is going to start as root 3 over 2, comma 1/2. Okay, the sign is going to depend on what quadrant you're in. So if you're in a 5 pi over 6, that's over here right before the end. So then your cosine would be negative and your sine would be positive. Your x is negative, your y is positive because you're in that third or second quadrant. When you have your pi over 4, those are always root 2 over 2, comma, root 2 over 2. Again, the sign is going to be determined by the quadrant that you're in. So you just have to look at whatever pi you have. If you're 3 pi over 4, 7 pi over 4, or just pi over 4. Finally, when you have pi over 3s, again, any number pi over 3, they're going to start with 1/2, comma, root 3 over 2. Again, the sign matters. I always remember these because over 6 divided by 3 is 2. 3, 2, 1. I go backwards that way. I know that they're 1/2 and root 3 over 2. As long as you know those are the numbers, you can kind of choose. So 6, 3 divided by 3 times 2, or 6 divided by 3 is 2. You know that the 3 and 2 go first. With 3, you go to 1. And so you know the 1/2 comes first. 4 is always root 2 over 2 because 2 times 2 is 4. That is not why, but that is how I remember it. Okay, within these coordinates, the first number is always your cosine. The second number is always your sine. So if you want to know the cosine of pi over 3, exactly pi over 3, the cosine of pi over 3 is 1/2. The sine of pi over 3 is root 3 over 2. And so you can, 5 pi over 6 is over here. So if you want the cosine of 5 pi over 6, cosine comes first, so it's root 3 over 2. But since we're over here in this third quadrant, it would be negative root 3 over 2. So on and so forth. Okay, so using that idea, sine of 135. 135 degrees is the same thing as 90 plus 45. So that means we're over here. We went to 90. We're over here, which is 3 pi over 4. Since it's a 45-degree marker, it's one of our over 4s. So pi over 4s are always a root 2 over 2. Since we're looking at the sine, that is the y value, which is positive because we're going up. So we're just going to use root 2 over 2. Then to get the cosine of 60, 60 is our pi over 3. This is a pi over 3, and that's just plain pi over 3 because it's in the first quadrant, which everything's positive. Cosine of pi over 3, here's cosine of pi over 3 is 1/2. So we're going to plus 1/2. When we add those together, lucky for us, they already have a common denominator. So we're going to have square root of 2 plus 1 all over 2. And I do want that exact answer. You'll lose a few points if you don't give me the exact answer. Okay, following the directions here, we're plugging, it gives us f of x and g of x, and we're plugging g into f. So it's going to take all of g and plug it into the f function. G goes inside of f. So if we start with our g is going inside f. So we've got 2, but instead of the x, now we're going to put x squared plus 1 minus 3, because we've got our 2x minus 3, but the x has been replaced. This is 2x squared plus 2 minus, it just doesn't like writing 2's, which is 2x squared minus 1. And that's your final answer. Domain and range of this function, I will give you a graph on the test as the note I wrote myself. So I will give you the graph of what the graph looks like. But here, square root function plus 3 means it's gone to the left 3. The square root function looks like this. And it continues all the way to the right and it keeps going up. So the domain is always your left to right, the smallest x to the largest x. The smallest x we have is -3. And because we have a closed dot, it includes it. We use a bracket. The farthest right it goes is to infinity. Our range is the lowest to the highest. So the lowest my graph goes is here at a y value of 0. Again, it includes that. It's not an open circle, not an asymptote, so we get a bracket. And then the highest it goes is it goes up to infinity. Excellent. Number 17, we are going to convert radians to degrees. Again, this is another formula that is on in the back of your book. So we're going to say 7 pi over 4 times 180 over pi. The pi's will cancel each other out. 180 over 4 reduces to 1 and 45. So now when we multiply across, 7 times 45 is 315. And there's just a 1 on the bottom, so 315 degrees. Or you can just look at your unit circle and figure it out. Give the reference angle in quadrant for 250. 250, we go 180, 250, let's see, 270 is there, so 250 is like this. Okay, so 250 degrees, here's 180, this is 250, so we have gone 70 degrees past the 180 mark. The reference angle is always the distance from the x-axis, the degree to the x-axis. So here, our reference angle is 70 degrees, and it's in the third quadrant. Number 19, we're going to graph this one. Here comes the graphing again. I'm going to give you another graphing one at this point. I forgot about that earlier. Oops. Oh, no, look, now you can do kindergarten. Hold the phone. There we go. We are going to graph this. So your normal parent function for sine it came back to life. My pen was dead for a minute. The normal parent function for sine starts here at 0, and then it goes up to 1, and then 0, and then -1, and then 0. I'm going to zoom in. Okay, we want 2 sine x minus 1. That means all of my y values multiply by 2, and then we go down 1. 0 times 2 is 0 minus 1, so it's going to end up down here, -1. 1 times 2 is 2, but then we subtract 1, so we actually end up right back where we started. 0 times 2 is 0 minus 1, so we go to -1. -1 times 2 would be -2, but then we go down 1 unit, so we actually end up down here at -3. And then all my x-axis ones are here, and we can graph a beautiful curve. Yay! Okay, find the first 4 terms, the geometric sequence. Okay, this is just telling me to write out the first 4 numbers that happen. Since it's geometric and we have this r, that means to multiply. So the first one is -4. Please get that one right because it tells you a sub 1. First one, -4. Then we multiply by 1/2. So -2, -1, -1/2. So -4 times 1/2 is -2, times 1/2 is -1, times 1/2 is -1/2. Okay, solve for the unknown sides and angles for the triangles shown. Hey, this is going to be your law of sines and cosines. So law of cosines, you're going to use for side angle side or side side side. Everything else you can use law of sines. Again, formulas in the back of the book. Make sure here I'll tell you that in a minute. Just kidding. Okay, so we are given a side, an angle, and a side smushed between. That's all the information we have. Therefore, we are going to use the law of cosines. The law of cosines tells me that c squared is equal to a squared plus b squared minus 2ab cosine c. So that's a lot of information. C squared, okay, we're going to look here. Because it gave me the angle, we're going to look for the side across from it. That's where we know how to start. So it gave me the angle of 56, so I'm going to start by finding the side associated across from it. 14 over here is A, and then 12 is B because we go opposite of the side that we're on. So C squared is equal to 14 squared plus 12 squared minus 2 times 14 times 12 cosine of 56. Okay, when we... Okay, I'm recording a video. So say hi real fast.
Hi.
Okay, goodbye. When you type this into your calculator, you can type this whole thing into your calculator at once. Please make sure you are in degree mode. Since you are typing in 56 degrees, make sure it is in degree mode. Otherwise, your answer will be very, very wrong. Okay, so when you type that in or type it in pieces, just make sure you type it in the correct pieces. When you type that all in, you end up with 152.11. We need to take the square root to get C all by itself. That gives me 12.33. So now we know our side C is 12.33. So we're going to plug in that just so we don't forget. 12.33. Okay, now we're trying to find angle B and angle A. We're just looking for angles. We have all of ours. Well, we don't have all of our sides. We do have all of our sides now. So we're going to use law of sines. Law of sines says the sine of an angle over the side equals the sine of an angle over the side equals the sine of an angle over the side. So you just match up sines and angles. You only need to use 2 of the 3 fractions in the formula. So we're going to start using C's as my base because we know both elements of C. So we're going to say, it doesn't matter which one goes on top. I'm just going to follow the answer key in the book. So 14 over, hold on, that's not what I wanted to do. We're going to, oh my goodness, 12. Seriously, this lack of writing 12s is making me crazy. Or 2s. 12.33, that's the side length of C, over sine of 56. Okay, so since I did side over angle, I'm going to keep with side over angle. I'm going to do A next because it comes first in the alphabet. So then the side for A is 14. The angle for A we don't know, so we're going to say sine of A. We cross multiply. 14 times sine of 56 is equal to, where did I write it down? Is equal to 11.606. That is equal to 12.33 times the sine of A. We're going to divide by 12.33. So that tells me that sine of A equals 0.9413. In order to figure out what sine of A is, we're going to find the inverse. That's where you do second sine on your calculator. So A is equal to sine inverse of 0.9413. Type that in. Again, make sure you're in degree mode because we want our answers in degrees. And we get 70.3 degrees. You get the idea. Okay, so we know over here that A is equal to 70.3 degrees. Then we can just subtract from 180. 180 minus 70.3 minus 56, because all angles add up to 180. When we do that, we end up with 53.7 degrees, and that is the measure of angle C. So here are our 3 missing pieces. Woohoo! Okay, finally, we've got the decay constant of a substance is determined to be that how much of 10 grams remain after a year. Use this formula where T is time in days and Q of T is the quantity remaining at time T. This 10 grams from the original problem is represented by this 10 in the equation. That's your starting value. It's where it goes in all of these fancy formulas. So now we're just going to plug in the information we have. We want to know how much remains. That's what QT is. QT is the quantity remaining. So we're looking for QT. Thanks, cutie. QT is equal to 10 times e to the negative k. Tells me my constant is 0.0069 times t, which is our time in days. It gave it to us in days, 365. You are just going to type this into your calculator. So you'll hit the 10. Then to get the e, you'll hit second natural log. It'll give you an e and a parentheses. Inside the parentheses, you're going to write, you're going to type in negative 0.0069 times 365, close your parentheses, and then hit enter. When you do that, you should get 0.806, and then give me units grams. So that means there is less than 1 gram of the decay constant. No. Oh, of a substance. There's 0.806 grams of the substance remaining after all this time. Okay, hopefully that was helpful to you. Hopefully this sound records for you. And let me know if you have any questions. Study, do these problems. The test is going to be shockingly similar. Use that formula chart. You can write in, oh, that's what I forgot to say. You can write in this stuff. You can write that onto your formula chart if you'd like. I'll be that super nice and use a unit circle. All those things are fine with me. All right, have a great